Welcome to Section 7, Lesson 2. In the previous lesson, we defined polynomials and locked in the 6-piece anatomy vocabulary of term, coefficient, leading coefficient, degree, and constant term. Today, we apply the vocabulary to the simplest polynomial operations, addition and subtraction. The good news is both operations reduce to a single mechanical rule, the like terms rule from way back in Section 1 of this course. Two terms are called like terms when they have the same variable raised to the same exponent. Like terms can be combined by adding their coefficients. Today, we lock in adding polynomials, subtracting polynomials with the negative distribution step, and writing the result in standard form. First idea on the board. Adding two polynomials means dropping the parentheses around both and combining like terms. The polynomial 3x squared plus 5x minus 7 plus the polynomial 2x squared minus 4x plus 1 equals 5x squared plus x minus 6. The work is term by term, x squared terms combined to give 5x squared, x terms combined to give 1x, constant terms combined to give negative 6. Like terms collapse, the rest stay as they are. The result is automatically a polynomial in standard form if both inputs were already in standard form, because the like term operation preserves the descending exponent ordering. Second idea. Subtracting two polynomials requires one extra step before the like terms work begins. Distribute the negative sign through the second polynomial. The polynomial 3x squared plus 5x minus 7 minus the polynomial 2x squared minus 4x plus 1 rewrites as 3x squared plus 5x minus 7 plus the polynomial negative 2x squared plus 4x minus 1. Notice that every sign in the second polynomial flipped. The plus 2x squared became negative 2x squared, the negative 4x became plus 4x, the plus 1 became negative 1. Once the negative is distributed, the problem reduces to plain addition combined like terms. The result is x squared plus 9x minus 8 in this example. Third idea. The like terms rule is the entire engine of polynomial addition and subtraction. Two terms are called like terms when they have exactly the same variable raised to exactly the same exponent. 5x squared and 3x squared are like terms because both have x squared. 5x squared and 3x cubed are not like terms because the exponents differ. 5x and 3y are not like terms because the variables differ. Like terms combine by adding coefficients while keeping the variable and exponent unchanged. Unlike terms cannot be combined and stay separate in the sum. The mechanical rule applies on every polynomial addition and subtraction problem in this section and beyond into the rest of algebra and calculus. Polynomial addition and subtraction reduce to combining like terms. Two terms are called like terms when they have the same variable raised to the same exponent. The like terms rule says combine by adding coefficients while keeping the variable and exponent unchanged. Unlike terms cannot be combined and stay separate. To add two polynomials, drop the parentheses around both and combine like terms. The plus sign between the polynomials means each term of each polynomial keeps its own sign. After dropping parentheses, group like terms together, add their coefficients, and write the result in standard form by descending exponent. To subtract two polynomials, distribute the negative sign through the second polynomial first, flipping every sign inside the second parenthesis. The negative becomes the multiplier for every term of the second polynomial. After flipping, the problem reduces to plain addition combine like terms exactly as in the addition case. The negative distribution step is the one extra move that distinguishes subtraction from addition, and the most common mistake is forgetting to distribute through every term rather than just the first one. The like terms rule expanded. 5x squared and 3x squared have the same variable x and the same exponent too, so they are like terms combined to 8x squared. 5x squared and 3x cubed have the same variable x but different exponents 2 and 3, so they are not like terms, cannot be combined and stay separate. 5x and 3y have different variables, so they are not like terms even though both have exponent 1, cannot be combined and stay separate. Constants like 7 and -2 are like terms because both have exponent 0 on every variable, combined to 5. The variable a and exponent match is the strict criterion. After the combination work, write the result in standard form descending order by exponent, leading term first, ending with constant. Standard form is the universally agreed convention for presenting polynomial answers, and every textbook, software, and homework problem uses it. Today we drill addition and subtraction on 2 worked examples and lock in the mechanic for the rest of section 7, where polynomial multiplication and division will both reduce to repeated additions and subtractions of polynomial pieces. Here is the worked addition example. Add the polynomials 4x cubed minus 2x squared plus 7 and 3x cubed plus 5x squared minus 6x plus 2. Write the answer in standard form. Step 1. Drop the parentheses. The plus sign between the polynomials means every term in both polynomials keeps its own sign. The expression becomes 4x cubed minus 2x squared plus 7 plus 3x cubed plus 5x squared minus 6x plus 2. Step 2. Group like terms. The x cubed terms are 4x cubed and 3x cubed. The x squared terms are negative 2x squared and 5x squared. The x term is negative 6x alone. The constants are 7 and 2. Step 3. Combine each like term group by adding coefficients. The x cubed terms 4 plus 3 equals 7, so the combined x cubed term is 7x cubed. The x squared terms negative 2 plus 5 equals 3, so the combined x squared term is 3x squared. The x term is negative 6x, unchanged because it has no like term partner. The constant 7 plus 2 equals 9, so the combined constant is 9. Step 4. Write the result in standard form by descending exponent. The result is 7 plus 3x squared minus 6x plus 9. Already in descending order from x cubed down to constant, standard form complete. Step 5. Verify the result has the expected pieces. The leading term is 7x cubed, the leading coefficient is 7, the degree is 3, the constant term is 9, 4 terms total, classification cubic polynomial. The 2 input polynomials were degree 3, and the sum is degree 3 because the leading coefficient sum of 4 plus 3 was non-zero. If the leading coefficients had cancelled, the sum would have been a lower degree polynomial. So the sum is 7x cubed plus 3x squared minus 6x plus 9. Lesson from this example addition is mechanical once parentheses are dropped and like terms are grouped. The work is the like terms rule applied repeatedly, no surprises. Practice on similar problems until the steps flow without conscious effort, because polynomial addition shows up continuously in multiplication, division, and equation solving in the rest of the section. Here is the work subtraction example. Subtract the polynomial 2x squared minus 6x plus 11 from the polynomial 5x squared plus 3x minus 4. Write the answer in standard form. Step 1. Read the problem carefully. Subtract a from b means b minus a, so the expression to compute is 5x squared plus 3x minus 4 minus the polynomial 2x squared minus 6x plus 11. The reading direction matters. The polynomial after the word from is the one you start with, and you take away the polynomial named first. Step 2. Distribute the negative sign through the second polynomial. The negative one in front of the second polynomial multiplies every term inside, flipping every sign. Plus 2x squared becomes negative 2x squared. Negative 6x becomes positive 6x. Plus 11 becomes negative 11. The expression becomes 5x squared plus 3x minus 4 plus the polynomial negative 2x squared plus 6x minus 11. Step 3. Drop the remaining parentheses and group like terms. The x squared terms are 5x squared and negative 2x squared. The x terms are 3x and 6x. The constants are negative 4 and negative 11. Step 4. Combine each like term group by adding coefficients. The x squared terms 5 plus negative 2 equals 3, so the combined x squared term is 3x squared. The x terms 3 plus 6 equals 9, so the combined x term is 9x. The constants negative 4 plus negative 11 equals negative 15, so the combined constant is negative 15. Step 5. Write the result in standard form. The result is 3x squared plus 9x minus 15. Descending order from x squared down to constant, standard form complete. Step 6. Verify the work by spot checking signs. The most common mistake in subtraction is forgetting to flip a sign during the distribution step. Recheck each sign of the second polynomial. Flip t plus 2x squared went to negative 2x squared, yes. Negative 6x went to positive 6x, yes. Plus 11 went to negative 11, yes. All three flipped correctly, so the answer is verified. So the difference is 3x squared plus 9x minus 15. The big lesson from this example is the negative distribution step. Subtraction is addition after distributing the negative through every term of the second polynomial. The single most common mistake on subtraction problems is flipping only the first sign and not the rest, which corrupts the answer immediately. Always distribute the negative through every term of the second polynomial. No exceptions, no shortcuts. 3 mistakes that catch every algebra student during their first weeks of polynomial addition and polynomial subtraction work. Each one is fixable with a small explicit habit applied on every problem from now on consistently. First mistake: combining terms that are not like terms. A student looks at 5x squared plus 3x and writes the answer as 8x cubed, somehow combining a degree 2 term and a degree 1 term into a degree 3 term. The mistake violates the like terms rule entirely. Terms with different exponents cannot be combined. The correct answer to 5x squared plus 3x is just 5x squared plus 3x unchanged, because no combining is possible. The fix is to always check the exponents and the variables match exactly before attempting to combine. If either differs, the terms stay separate. Second mistake: forgetting to distribute the negative sign through every term of the second polynomial in a subtraction. A student looks at the expression a minus the quantity 2x minus 7 and writes a minus 2x minus 7, flipping the first sign of the second polynomial, but leaving the second sign alone. The minus 7 should have flipped to plus 7, and the failure to flip both signs corrupts the answer. The fix is to always rewrite the subtraction explicitly with a leading negative and brackets, then distribute the negative through every term of the bracket without exception before doing any combining. Third mistake: reversing the direction of subtraction because of the English wording. A student reads subtract a from b and computes a minus b, when the correct interpretation is b minus a. The English phrase subtract x from y means take x away from y, so the result is y minus x. The fix is to write the problem in symbolic form before starting any algebra. Identify which polynomial is being taken away. The one after the word from is taken away, and which polynomial it is being taken away from. The one after the word from is the starting polynomial. Polynomial addition and subtraction show up across calculus, numerical computing, symbolic computing, and coding theory continuously. 4 broad sectors below where every working professional applies these basic polynomial operations routinely. In calculus, the derivative of a polynomial is found by differentiating each term and adding the results. Each term differentiation reduces to one line work. The derivative of x to the n is nen a x to the n minus 1. The total polynomial derivative is the sum of all the term derivatives, exactly the polynomial addition mechanic from today. The integral of a polynomial works similarly, term by term, with addition combining the integrals at the end. Polynomial calculus is therefore polynomial arithmetic in disguise. In numerical computing libraries like NumPy and SciPy in Python, MATLAB and Julia, polynomial objects are represented internally as coefficient arrays, and addition and subtraction of polynomial objects is implemented as element-wise array addition and subtraction. Exactly the like terms rule applied programmatically. Every numerical analyst, engineer, and scientist who works with polynomial regression, polynomial root finding, or polynomial fitting uses polynomial arithmetic constantly through these libraries. In symbolic computing systems like Mathematica, Maple, and SymPy in Python, expressions are represented as polynomial sums internally, and the addition and subtraction operations apply the like terms rule symbolically. Computer algebra systems can simplify, expand, and factor polynomial expressions of arbitrary complexity, all built on top of the basic addition and subtraction primitives from this lesson. In coding theory, error correcting codes used in cellular networks, hard disks, and deep space communication represent code words as polynomials over finite fields. Encoding and decoding operations reduce to polynomial arithmetic in modular contexts. Read Solomon codes used in QR codes and DVDs and satellite communication build entirely on polynomial addition, subtraction, and multiplication, and the foundational structure is the polynomial machinery introduced in Section 7 of this algebra course. 3 things to take with you from this lesson today. Polynomial addition and subtraction are the simplest polynomial operations, and they reduce to the like terms rule applied mechanically. Today's mechanic is also the foundation of polynomial multiplication, polynomial division, and polynomial calculus in later lessons of this section. First, 2 terms are called like terms when they have the same variable raised to the same exponent. Like terms combine by adding their coefficients while keeping the variable and exponent unchanged. Unlike terms with different variables or different exponents cannot be combined and stay separate. The like terms rule is the entire engine of polynomial addition and subtraction. Everything else is bookkeeping. Second, to add 2 polynomials, drop the parentheses around both and combine like terms by adding coefficients. The plus sign between the polynomials means every term in both polynomials keeps its own sign. After grouping and combining, write the result in standard form by descending exponent. The work is mechanical and produces exact answers reliably for any pair of polynomials. Third, to subtract 2 polynomials, distribute the negative sign through every term of the second polynomial first, flipping every sign inside before doing any combining. After distribution, the problem reduces to plain addition. The most common mistake is flipping only the first sign of the second polynomial and not the rest. Always distribute through every term without exception. Coming up next, the lesson called Multiplying Polynomials, which extends today's term-by-term arithmetic to the next operation. The distributive law applied repeatedly is the new mechanic, and the resulting product is itself a polynomial whose degree equals the sum of the input degrees, and whose leading coefficient equals the product of the input leading coefficients. The lesson teaches the core multiplication mechanic for all the polynomial work in the rest of this section.